Hi guys, welcome to my channel, and today we're going to continue to do transformations, and let's do it. Start from 3F. Before 3A to 3E, we learned how to determine the transformations and what a transformation is, right? DRT, Dr. T relation means dilation, reflection, and transformation and translation. Okay, so for this videos, I just want to introduce some concept or some ideas about using transformations to sketch graphs and to help you to understand how it can works. Okay, so for before we're doing any transformation, you have to familiar with the old one, which means the basic one, right? For example, like y equals 1 over x, and you want to draw like this guy, y equals 4 over x plus 5 minus 3. So if you don't know the graph of 1 over x is rectangular hyperbola, it's no way you can draw this graph, okay? But you always can find one way to save you, because you always can use substitute some method, some points and some dot to help you familiar with what this graph gonna looks like. Okay, again, we rearrange the formula for the mapped functions and get this one. Okay, to make sure you always do this. Again, the first one is dilation factor 4 from x-axis, and translate -5 units in the negative direction. Sorry, translate 5 units in the negative direction and translate 3 units in the negative direction of the y-x-axis. Okay, based on this, we can directly draw the graph, which gonna be looks like here. Okay, so this page 120, this example explain every single step in details. Okay, that is how we use transformation to draw graphs. And again, for this kind of graphs, we need to make sure you write down some key features. The first important one is asymptotes, if they have any. Okay, the second important one is x-axis intercept and y-axis intercept. Okay, the third important part is our general shape. Okay, so if you meet all the criteria for these three, and if it's in exam 1, you should get 4 marks. And make sure if they ask you to draw graph in exam 2, make sure you're setting the windows and make your graph as accurate as possible. Okay, and now again it asks you to sketch the graph of negative square root of x minus 4 minus 5. So again, this function is obtained from y equals square root of x. So it's do the reflections over here and do some translations, right? And sometimes you're gonna say, "Sir, I'm not really sure, what to do." Okay, I will teach you another method. Just plug in some numbers. Okay, just plug in some numbers. Then you can get an idea about this graph, because you know the general shape of this one. It looks like this, right? So if I plug some numbers in here, like 4, like maybe 5, or like another number easy like 8, so gives us idea about how this graph looks like, and just connect them. Okay, and for the next one is like the truncus. Okay, so for truncus, the basic graph is like this. Okay, and again we need to figure out the asymptotes to get the idea of this. Okay, that would be the whole thing about 3F. And another one is transformation of power function with positive integer index. This one is again straightforward, and which is not that important, because in following chapters chapter 3, sorry, chapter 4, and we're gonna discuss more in detail about these polynomials, and not only for the power functions, okay? And the rest of this part, they ask you to determine the point, and just make sure for the degree of 3, which is the y equals x to the cube, we have some point called the point of zero gradient, and this is essentially the special point. And later on, you guys will know this is the stationary point, or we call it point of inflation. But until now, it's not that important. You just need to know it's a point of zero gradient. Okay. And 16 is essentially the same thing for combined with what we learned for 3E and 3F. So it's just like tell you the transformations and just follow each steps. And for part A and for part B, you just need to figure out the middle steps. So which means you know the original functions and images. Okay, so you just need to find the bridge between them. Okay, so that would be 3G as well. And for 3H, it's another straightforward. Now we give you the rules and we give you some point. Then we ask you to determine what the graph or what's the relation or what's the function looks like. Okay, so we can skip this two. It's 3H and it's also straightforward. And now for 3I, it's become essential for us, and I really want to talk about the matrix transformations. In here, I just want to emphasize one point, okay? So my point is, if you, in the final exam, you see this one, okay? Txy equals to here, and xy, and plus something, something. For the left-hand side, for this guy, it's always after transformation, and this guy is always before the transformation, okay? So if it means reflect in the x-axis, which means xy change to x negative y, right? So x remain the same. In matrix, it represents 1, 0 because 1 times x plus 0 times y give you x dash. And you realize y dash becomes negative, so you just plug in 0, negative 1. That's how we get the matrix, and that's again how we from matrix back to our functions or linear equations. This is essential skills you need to have, and it's required. Okay, let's just talk about more about this one. So for this one, under the transformation, let's convert it into our linear functions. Okay, so this one means my x dash y dash equals to 1, 0, 0, negative 1, and xy. So which means my x dash is x and my y dash is negative y, which means reflection in the x-axis. So essentially you do need to remember this one because it's impossible, it's hard, and it's tedious. Okay, that's why I'm introduce you guys this method to help you to familiar with how to convert each other and help you answer the problems. Okay, so let's move on to the next one. Again, consider linear transformation such that 1, 0 to 3, negative 1, and 0, 1 to negative 2 and 4 find the image of 3 and 5. That's the problem over here. So, because we know the one point is 1, 0, and we know that point 0, 1, and we need to figure out AC and BD, which means it's a transformation matrix. Okay? So, first we need A times 1 equals 3, and B times 0 is 0, and plus, and the next one is C times 1 plus D times 0. So that's why we know A and C. And again, for the next one, that's how we know BND. So this is the key step over here. Make sure you understand this one and use it as much as you can. Okay. And this is example 22 and 23 are essentially the same thing. Okay. And due to the time constraint, I'm just gonna be stopped over here. And later for the next one, I'm gonna talk about more about transforming graphs and about how to use matrix to determine the transformations. And for my next video, of course, once we've done this one, I will give you some exam questions to familiar with these topics. And okay, guys, hopefully my videos help you a little bit. And please click like and subscribe my channel. Okay. See you guys for next videos. Bye bye, guys.